Hello everyone, my name is Anik, and I am working as a graduate research assistant at University of Arkansas in the Department of Civil Engineering. Today I am going to talk about the impacts of different parameters of CSS on particle size compared to the other asphalt emulsion. I have divided I have divided my works into three parts. First of all, I'll be going to discuss about the introduction of asphalt emulsion, and then the classification and the background. And after that, I'll discuss about the effects of asphalt emulsion, effects of particle size on asphalt emulsion based on the previous research articles and my future works. So, what do you mean by asphalt emulsion? So, asphalt emulsion is nothing but two immiscible liquids that are fully dispersed, and emulsifier is used for this dispersion. And for this dispersion, emulsifier can be acid or base. Uh, so there will be two types of asphalt emulsifier. One is cationic and another one is anionic. There are two sides of asphalt emulsion. One is heat part and another one is tail part. Heat part is more than water loving, and tail part is well loving. So as we can see from this picture that head part is attached to it water and tail part is attached to it asphalt, which is oil. So this has the separation of water and asphalt droplet. This emulsifier makes it ensure that water and asphalt droplet will not mix with each other. So there are three components on asphalt emulsion. One is asphalt that will be on 64%, and another one is water that will be 33%, and another is chemicals like emulsifier, acid, base, etc. That will be 3%. So mainly the asphalt emulsion was begin on the paving application in the decade of 2000. But at first it faced some obstruction, but initially it is developed in the 1970s decade. And there was a using of asphalt cutback, but it is very much energy consumptive, so that's why to reduce the energy consumption and to reduce the heat, the asphalt emulsion is highly encouraged to apply on the road pavement. So as asphalt emulsion has no petroleum and has no heat, so there is less energy consumption, and so it is very much environmental significance. So there are mainly three types of asphalt emulsion. One is rapid set, another one is medium set, and slow set. Based on the emulsifier doses, they are categorized. If the emulsifier doses is higher, then it would be slow set. If the emulsifier doses is lower, then it would be rapid set, because emulsifier doses makes the separation between water and asphalt emulsion, water and asphalt droplet. So that's why it ensures the separation and dispersion. But the for the rapid set emulsion, there will be less emulsifier doses. That's why they create less separation, less dispersion. So that's why they will be broken very quickly. So there is some nomenclature that is used for the asphalt emulsion. One is H, which represent hard penetration, and one which represent low viscosity. Two, it is a representation of high viscosity. Uh, P or L, which is a representation of polymer or modified latex, modified, etc. So mainly, there are some factors that affects the asphalt emulsion. One is particle size distribution, and another one is asphalt content. So if the particle size, the variation of particle size will be higher, there will be low viscosity, and if the viscosity is will be lower, there will be more settlement and there will be more breaking of the asphalt emulsion. So they mean basically a rapid set emulsion. And if the particle size variation little bit lower, then there will be higher viscosity and they will affect on the settlement, and they will be slow set. And yes, and similar type of things for the asphalt content. If the asphalt content will be higher, there will be high viscosity and they will be less settlement, they will be stable. But for the low viscosity, low asphalt content, there will be low viscosity and they will be unstable. There are two types of things, that is flocculation and coagulation, that is categorized based on the particle size. Flocculation is mean by that the particles start clogging to each other, but coagulation is mean by that they are fully stick to each other, they are fully clogging to each other, so their particle size is little bit higher. And it is mainly due to the prolonged time of storage and less chemicals that have been used for the asphalt emulsion. So based on the previous research, you can see that there are two types of asphalt: ASS one and ASS two. ASS one is little bit low emulsifier doses, and ASS two is little bit higher emulsifier doses. So if we can see that from the graph, as there was a higher emulsifier doses, uh, it is it is a less storage stability. But if the emulsifier dosage is lower, the storage stability higher. What do you mean by stability? Stability is nothing but the phase difference between upper and lower portion. So if storage stability is higher, so there will be more settlement, and particle will be more unstable, and they will be more breakable. So this is the difference between ASS1 and ASS2. Similar type of things for the storage time and particle size. If we see it from that graph, there is a difference between particle size for the ASS1 and ASS2. As storage time is higher, the particle size will be higher. But as the emulsifier dosage is higher for the ASS2, so that's why particle size is a little bit lower compared to the ASS1. So that's why this is the main advantage of ASS2 for the slow set emulsion, and ASS1 should be rapid set emulsion. There is a contradiction with the Keen et al. Research article, that there is a mention about that the coalescence when occurred, there will be higher viscosity. But as we can see that from the previous article, that coalescence is a meaning of the particle clogging. So when particle clogs with each other, they will settle down and there will be more less viscous, and they will be rapid set immersion. But CSS is more and less slow set emulsion. This is the main contradiction and limitation of this article. So my future work will be on particle size analysis, and I'll be analyzed more about on cationic slow set emulsion for the viscosity with other asphalt emulsion and compare them with that. And I also measure the softening point, and by softening point, what will be the uh, asphalt emulsion quality I'll have to measure. And then the anionic and cationic asphalt emulsion, because anionic is more stable. So I need to find out why anionic is more stable than cationic. So thank you.